So students, today we are going to study about thermodynamics. So before learning thermodynamics, we must learn what exactly thermodynamics is. So thermodynamics is the branch of science that deals with the energy transfer and its effect on the state or condition of the system. So basically, we will study about how the energy transfer will impact on a system or a state. So in thermodynamics, there are basically four laws. The first law is the zeroth law that deals with the thermal equilibrium and it relates the concept of equality of temperature. And the second one is the first law, which pertains to the conservation of energy and introduces the concept of internal energy. The third law is the second law, which relates the direction of flow of heat and dictates the limits of conversion of heat into work, that introduces the principle of increase of entropy. Then the last one is the third law that defines the absolute zero of entropy. And these laws are based on experimental observations, so they do not have any mathematical proof. So now we will study about the different applications that are involved in thermodynamics. So these are the key sectors like automobile engines, turbines, compressor and pumps, propulsion system in aircrafts and rockets, the combustion system, HVAC system for refrigeration purpose, the cooling of electronic equipments, the power stations like nuclear, thermal, etc., alternative energy system and biomedical applications. So these are the different areas where the thermodynamics plays a vital role. So in this diagram you can see that represents the thermal station, the vehicle engine, refrigeration, hydropower station, turbojet engine and biomedical applications. So this image just represents the various applications of thermodynamics where it is used. Now moving on, another important topic is macroscopic and microscopic point of view. So it is well known that every substance is composed of large number of molecules, and the properties of the substance depends on the behavior of these molecules, and the behavior of the system may be investigated from either a microscopic, which means small, and macroscopic, which means large or big. So these are the basic differences between macroscopic and microscopic, where we can summarize that these two as they are like microscopic, it is an approach. A certain quantity of matter is considered without taking into account the events occurring at molecular level. Whereas microscopic, the matter is considered to be comprised of large number of tiny particles known as molecules, which moves randomly in chaotic fashion. And the effect of this molecular motion is considered to be microscopic approach. So these are the rest of the features. We will only highlight the important features, like a few properties are required to describe the system and a large number of variables are required to describe the system. Then the properties of this system are their average values, and the properties in microscopic approach are for each molecule individually. So these are the key differences between the microscopic and microscopic approach. And moving on, we will see the thermodynamic system and control body. So thermodynamic system, it can be defined as a quantity of matter or a region in the space upon which attention is concentrated for investigation or analysis of thermodynamic problems. such as heat transfer in a particular space and the impact on the system. Then the surroundings or environment, that basically represents the matter or a region out of the system. Like you can see here, if this is the system, this is the boundary of the system, and the substances or the objects that are beyond the system are called the surroundings. So we can simply say that some system plus surrounding equal to universe. So universe is the combination or the summation of system and surrounding as represented in figure 1.2.